welcome to another lesson. Before we start, I gotta tell you, I just recorded this whole video, the whole thing, front to back, all done, whole kit and caboodle. And I looked back at the recording, and it didn't record the audio. So, round two. Can't always get what you want, I guess, when it comes to online teaching, but I just want to let you know that, yeah, round two for me. Okay, page 10. This is the last video for this unit, unit 7, page 10. We're going to solve more problems. We're going to use the quadratic formula to solve these, even though it doesn't look like it from the beginning. We're going to solve these word problems by setting the whole equations up, forcing it into a quadratic equation form, ax squared plus bx plus c, and then we're going to use the quadratic formula to solve it and see what happens. All right, let's get started. So the first question says, 2 pipes together can fill an oil tank in 6 hours. All right, this looks familiar. These are these things where it's like something plus something equals something where you do things together, right? So this is from the last unit. So 2 pipes together can fill an oil tank in 6 hours. 1 oil tank, 6 hours. So we've done one job or one thing of work per some given unit of time. And it says if used alone, one pipe would take 2 hours longer than the other. So in order to do the job, one pipe would take 2 hours longer than the other. Well, one pipe must take some mysterious amount of time, t, and the other pipe must take 2 hours longer than that time, t. And then it says how long does it take each to fill the tank if used alone. Okay, so we've got our equations set up. We just need to solve for t now, which first things first, we've got to deal with our LCD in order to deal with this, which you should remember. And if you pick out this carefully, you should get 6t and t plus 2. So make sure you don't forget about the things that you learned in previous units. You never know when they're going to come back and be useful in a future question. So I'm going to take this and I multiply it by each of these separately, right? That's kind of our steps to take. So if you multiply them all out, this is what you get. Almost caught myself there, tossing x's in there. I'm just so used to doing x's. So if you multiply them all out, that's what you should get. And now I'm going to expand these. And we see something that we never usually saw in our last unit. In fact, we never saw it at all. We got a squared term in a question like this. Thankfully, that's not a big deal. What I'm going to do is try to get everything in our quadratic form, right? We want our squared term first, our x term or constant variable term next, and then our constants, and then we want 0 on the side. So I'm going to move everything onto the right side, actually. I'm going to move these all over to the right side of the equation, and the left side will be left with nothing, which means it'll be equal to 0. So lots of ways I could have done that. I could have simplified the left side first. It doesn't really matter as long as we get everything to one side. And now I'm going to simplify the right side and put it into this form here. All right, now we have something we can work with. We can put this into the quadratic formula with very little difficulty. How do I know that? Well, I know the term in front of the squared is a 1. The term in front of just the t, the coefficient is -10, and the constant term is -12. And if I know that, I can put it into my quadratic formula and solve, and everything should be fine. Should be. Let's see what happens. Just a reminder of what the quadratic formula is. Be very careful to put in the correct coefficients. There we go. And if you're really careful, this is what you should get. Okay? Make sure you calculate out that radical as carefully as you can. You should get plus or minus square root of 148. Now we have a bit of a problem. That is not a nice time. If someone was like, how long does it take you to do this job, and you gave them that number, they'd just look at you funny, wouldn't they? So we want to take our positive and our negative answers of this, and we're going to convert it to decimals. So I just said, give your answers in decimal form. That will be something more useful for someone, okay? So it makes more sense when we're dealing with time. If you take the positive version, you should get 11.1 hours. And if you take the negative version with the negative sign, you get negative 1.1 hours. So let me just talk about this for a second. 11.1 hours is a reasonable amount of time. Negative 1.1 hours to do a job is not reasonable. We need to reject it. I should say specifically why. We want to reject the negative. And why is this? Normally we don't do that, but in case of a word problem, when we're dealing with how long does it take to fill a tank, it makes 0 sense to have a negative time. You can't start a stopwatch and then your clock goes backwards. It's just not how things work. So we cancel that out. We reject that answer. And once you've rejected that answer, we can finish our question. So in the beginning here, it says, how long does it take each to fill the tank if used alone? So we know t, and now we can easily get t plus 2. Okay, we'll say tank 1, for example. They don't have numbers, but I'll just say it's 11.1 hours. And then tank 2, the other two that does it in 2 hours longer, that'll be 13.1 hours. And written out in words, it will take one tank 11.1 hours working alone, and the other 13.1 hours. And the reason I got 13.1 is it's the other time plus 2 hours. Okay, that's how you do this question. So lots to chew on there, right? You had a word problem that you had to figure out. You had to make the equations for it. You had to use your LCD to work out what it's going to be, to cancel out those fractions. You needed to get that into quadratic form, and then you could use your quadratic formula here. And then you had to reject the negative answer and then finish the question. So lots and lots to chew on. Hopefully, by seeing this, you'll be able to handle one like this in the future. And I went through it quickly, so make sure you take your time and go through every single step if you're confused at all. Second question, a projectile, or an object, is fired vertically upwards. So it could be a bullet, it could be a cannonball, it could be a baseball someone threw in the air, it doesn't really matter. Its height, s, in meters above the ground at time t in seconds, is given by s equals 90t minus 4.9t squared. When will the projectile hit the ground? Well, let me just tell you a little story here. You're shooting an object into the air, it goes straight up and comes right back down, okay? I'm not making it go straight up and down on itself, because then I just make a line. But for all intents and purposes, assume that that's being fired straight up. The height above the ground, this height above the ground is s, okay? And the time is just the amount of time that would be ticking on by if you clicked a stopwatch as soon as you shot this thing. It says, when will the projectile hit the ground? So we kind of have two times that are going to come out of this. We have the start time. I'm trying to get my computer to do what I want it to. So we have the start time, because the time is equal to, okay, we don't really care about the time, but the end time, what's the time going to be? So let's just check the question. It says, when will the projectile hit the ground? Okay, so first things first. This first time, we're probably going to end up rejecting a time. I'm not sure. I'm not entirely sure. I have a feeling that it might be time equals 0. Because before you start shooting anything, the stopwatch is at 0, right? As soon as the bullet's fired, for example, it's going to be time 0. This is probably the time that we want. The mystery time after some time has passed. So I'll come back to that idea later, but I just wanted to set the scene for you. So first things first, when will the projectile hit the ground? The projectile hits the ground when the height is 0. So there is no distance in the air. It's not in the air anymore. In other words, that means that our s is 0. What's going on here? Sorry, my Surface is really fighting me. The Surface is the device I use to record these things. But I'll get through it. Okay, hits the ground when the height is 0. In other words, s is 0. Why does that help us? Well, look at our formula. Our formula is height above the ground is 90t minus 4.9t squared. But we know that at time is the height is 0 at the time we're looking for. So set that to 0. You get something a little simpler. And that's a quadratic. But it's not in the form that we want it. So to get it into the form that we want it, let's just move everything to the left side, okay? Let's move the constant, this term over, let's move the quadratic over. And let's actually move the 0 over as well. Yes, you can do that. If we empty one side, the other side will just be 0. So what do we got on the left? 4.9t squared minus 90t equals 0. So we moved everything from the right side, and now the right side is now 0. So you don't really need to think of it as moving the 0 over, just think of it as the side is now empty. Why did I do this? I got it because I wanted it in quadratic form, which means squared terms first, then your linear terms, and then your constant terms. If you match this up, we actually have all the pieces to the puzzle. A is 4.9, B is negative 90. C, what's C? There's got to be a C. Well, there's no term there, so you just treat it as 0, okay? So C is 0, and that's perfectly fine. You're allowed to have C equal to 0. Now that you have that done, you can solve using the quadratic formula. I'm not going to talk through this very much. I'm just going to write it out. But make sure you try it on your own to make sure you get the answers, okay? Because of this 0, C equals 0, we can cancel that whole term. You can calculate it out or just try it by hand. The calculator will tell you the same thing. This works out to the following. Okay, you might wonder where that 90 came from. It's just negative 90 all squared, and then I get the square root of it. It kind of cancels itself out, right? 9.8, fun fact. This is the acceleration of gravity, which if you're doing physics, you should recognize that number, 9.8, 9.81, things like that. Just a little bonus. This is a projectile being thrown into the air, so it's going to be under the force of gravity, which is why that term shows up in here. Just a little, bit of trivia almost. So the positive version of the answer would give 18.4, and I'd expect you to calculate that out yourself to check to see that I'm not crazy. The negative version, turns out that if you work that out, you get negative 90 minus 90, and we eventually end up getting a 0 seconds. So our answer here is 18.4. And we get a 0 as well, which is not that helpful. So let's go back to our picture at the start. Which one of these answers is correct? Well, this is before it even got shot. It's right as soon as it got shot out of the cannon or gun or whatever we're talking about. We care about the 18.4 seconds after it has been in the air for a while. Okay? So there is a little bit of extra thinking for these questions. You need to consider the case, something going up, coming back down. We don't care about the time at the beginning, we care about the time at the end. Okay? After it's been in the air, how long did that take to hit the ground? So take time to think through that. If you have some real trouble with that, please just email me, let me know. I'll do my best to help you through it. For B is actually kind of an independent question from question A. It says, at what times will the projectile be at 250 meters above the ground? So what this is really asking, let me draw another picture. Comes up, comes back down. At what times will the projectile be at 250 meters above the ground? So at some point along its trajectory, it's going to go up high, obviously, and come back down. Let's just say that at some point, it's got to cross this height of 250 meters, right? It's got to. Sorry, one second, my son is distracted. Okay, so 250 meters. So there's going to be, we should expect 2 times out of this, which is what's nice about quadratic formulas and quadratic equations. They give us 2 answers because in real life, there's lots of cases where 2 solutions might be better than 1. So there's 2 different times. One time we're going to get out of this on the way up, one time we're going to get out on the way back. If you didn't know that ahead of time, that's perfectly fine. And do you know why? It's because in this question, it's giving us the height above the ground. So we know that our S is 250. You could go into this question without knowing anything else, and you could get this question done. Okay? So remember our equation given in the beginning. Our equation was S equals 90t minus 4.9t squared. But we know our S. Our S is not 0 in this case. Our S is 250. And that's shaping up pretty nice, except I've got this negative term in front of the A, which is never nice. I'm going to move everything to the left, and it should tidy this up quite a bit. And move both of those terms over to the other side. And now I've got old reliable, the quadratic formula here. So I'm not going to set a, b, and c separately now. I'm just going to save a little bit of time and some space and just write it out directly. But if you are having any trouble following along, you should write what a, b, and c are here. So one thing I'd like to point out, in fact the only thing really different about this question, is that in this case our c is not 0. So this term doesn't cancel out, it's going to stay in there and we got to deal with it. Thankfully that's not actually difficult, and I'll write out what I got for this and see if you can get this on your own. Alright, so this inside piece should be 3200. Make sure you can get that without moving forward. If you don't get that far, then there's no point of you going further, okay? You've got to get that first. Now that we've got this crazy, or at least kind of ugly, answer going on, remember we're going to be dealing with decimal answers by this point. It was easy to deal with whole numbers and everything up until this point, but now that we're going to try to solve this, it doesn't simplify nicely. Just going to get the decimal answers because the answer is a time anyways. So let's take our positive answer and our negative answer, treating the plus and minus, right? So our t, if we take the plus, 14.96 seconds. Sounds reasonable. T, if we take the minus, 3.41 seconds. All right, both of these are not negative, so it looks like we can accept them both. What do they mean? What is going on? Why the heck do we have 2 times? Well, you can pause the video, think about it, but I've already explained this. Let's relate back to the very first thing I wrote. At what times will the projectile be 250 meters above the ground? Well, in the beginning here, that must be the 3.41 seconds, because that's on the way up. And then the 14.96, that must be on the way down. And I hope that makes some sense. I'll do one more little picture for you. So let's just say we have up and down. Yep, it goes up, hits our 250 meter mark, keeps going up, takes a while. After 14.96 seconds in total, it hits that point. This is our 250 meter mark. This amount of time took 3.41 seconds, and then all this amount of time took 14.96 seconds. Okay, so that's more of a watch it through the video type of thing. It doesn't look like much when you look at it like this, but just rewind that video and watch that a few times and see if that makes sense. Think of it as like a stopwatch clicking on over. If you have trouble with making sense of that, let me know. I'll go through another example with you. But let's move on to the final question in this unit, and the final question on quadratic equations. Question 3. A rectangular solar panel is 80 centimeters by 24 centimeters. So we got a rectangular panel, 80 by 24. Maybe we'll need that, maybe we don't. By adding the same amount to each dimension, the area is doubled. Okay, so by adding some amount to each dimension, plus x, the area is doubled. How much is added? Tricky one. Let's see, the area in the end. Area is normally length times width, right? But if we double the area, it's going to be 2 times length times width. So let's see if we can piece all this together. It says by adding the same amount to each dimension, the area is doubled. How much was added? Let's set up the area formula. So, one dimension, 80 plus x. Another dimension, 24 plus x equals double the original area. Maybe let's look at it another way. Originally we had a solar panel, 80 by 24. So 80 by 24 is our area, right? 80 multiplied by 24 is the area that we started with. Okay, that's our original area. If we add this to both sides, maybe I'll make 2 diagrams. This is saying that it's doubling the area, right? Maybe I'll make a diagram for the original now. So this is our new area, and this is original area. You don't need to draw any of this, I'm just trying to make sense for you. The 80 was our original length, 24 was our original width, so this is our 80 times 24 is our area. Okay, hopefully that makes sense. Length times width is our area. Oops. Got a little excited there. And then in our new area, length times width is area times 2. So length, width, area. Maybe I'll write that out and then we'll move from there. Length, width, new area. The whole point was to get to this form, and then we're going to expand this out and see if we can solve for that x, because really we want to know how much is added. So our final answer is going to be, what is our x? Okay, let's expand this, see what happens. Multiply the first ones together, 80 times 24, that's 1920. Multiply the outside ones together, that's 80x. Multiply x times 24, that's 24x. Multiply x times x. That's x squared. That's where our quadratic comes from. Multiply all the right side, you get 3840. Okay, so we've got our squared term. That's great. We're going to be able to use the quadratic formula on this later. Let's tidy it up. Let's simplify the left side and bring everything on the right side to the left. So really all I got to do is bring this over. And take a minute, pause the video, simplify the left side, and then see if you can get it into ax squared plus bx plus c form. This is what I get. So do that yourself, see if you make the same, can make the same numbers come out. Now we've got a, b, and c, right? We've got a equals to 1, we've got b equals to 104 here, we've got c equals to negative 1920. Just toss it into quadratic formula, let's see what happens. Okay, so in this case, we actually don't need to deal with decimals. If we don't want to, you can try, but it's actually going to come out to whole numbers. So if we take the left side, we're going to get 32 over 2. In other words, the amount added must be 16 centimeters. I'd box that. That sounds perfectly reasonable. If we take the negative version, we have negative 104 minus 136. What's that? Negative 104 minus 136. That's negative 240 over 2. That's not looking good. That's negative 120. Looks like we're going to need to reject that one. You can't have a negative. You can't add a negative length. Like you're trying to make this bigger and making the area bigger, not smaller. So that negative makes no sense whatsoever. So I'm just saying reject negative dimensions. So at the end of the day, we have our answer. It says how much is added to each side. It must be 16 centimeters to each side. So to fully answer the question, I'll just go back to here. Sorry for zooming around so much here. If 16 centimeters are added to each dimension, the area will be doubled. All right, so if 16 centimeters added to each dimension, the area will be doubled. And let's just do a quick check. Let's just take a look. The original, so the old dimensions versus the new dimensions. Let's just do a versus match, right? Death match between old and new. What are the old dimensions? The old dimensions are 80 and 24. So the area is length times width, which is 80 times 24. Let me put it in brackets so that I don't confuse you. 80 times 24, what's that? I think I had it done earlier, but I'll do it now again. 1920. That's centimeters squared. So with our new extension added, we should double that area. And that might be useful for someone. That's still length times width. But our new is 80 plus 16, so 96. And then 24 plus 16, which is 40. And we should, if everything works out, that should be double the original area. 3840 centimeters squared. Is that double? It is. So it's double. That's good. I'll just write here that that is a check, by the way. You didn't need to do that. I just wanted you to think about this. The old one, if you take those dimensions, multiply it by 2, you're going to get the new dimensions, the new area. So we've sufficiently solved that. Okay, well, I hope that didn't throw you for too much of a loop. I hope you can start to see why using quadratic formula, using quadratic equations can be useful for solving these types of problems. And if you had any issues with this whatsoever, please let me know. I'm happy to review them in another class or in person. Well, not in person, but online. Send me an email. I'll set up a session for you. Have a great day.